Okay, so just to recap what we just did is I changed this to be the same as this. Now, what you have to remember is that I can't make 3 into 81 without multiplying by something. But if I multiply something to this side, I have to multiply it to this side. So that's only going to keep making this one even bigger. But we can write larger numbers as smaller numbers with an exponent. So what you want to do is look at the bigger number and figure out how you can get the bigger number to be the smaller number. So that's what you're going to look for when you start each question. And then something else that I kind of went over really fast is remember from Math 8 that when an exponent has an exponent, you multiply those exponents together. So that's where I got the 20. All right, let's try another one. Okay, hold on, let me move around a little bit. All right, so example 2. So this one is easier. 2 to the 3x equals 16. All right, so starting off, I need to get the base number to be the same. So I'm going to look at the 16 and figure out how I can write the 16 as a 2. So think. I know that 16 is 2 to the 4th. And now that matches 2 to the 3x. So all I'm doing is I'm just substituting the 2 to the 4th for the 16. The value is the same, so I'm not changing the equation at all. I'm just rewriting it a different way. And now the bases match. So once the bases match, I'm basically ignoring those and solving the equation that is created from the exponents. So 3x equals 4, divide both sides by 3, so x is 4/3. And there's the answer for that one. All right, so let's take a second and write the steps so that you have the steps written down. So, step number 1. Create matching base numbers. Create matching base numbers. So remember that you want to look at the larger base and figure out how you can write it to be the smaller base. So we don't typically change the smaller one, except of course we will. So step 2 is solve the equation or inequality. It can be an inequality also from the exponents. So first we have to create matching base numbers, and then we will solve the equation that we get from our exponents. All right, so I'm sure you're wondering, is there ever a time where you might have to change both of them? And the answer is, of course. So I'm going to move on to example 3. All right, so for this problem, let's say that we have 16, x minus 5 is that exponent, and 64 with x plus 3 as that exponent. All right, so we have to get the base numbers the same. So I'm going to look at 64, and I think I'm going to just mention that we have an audience today, so I might get some helpers out here to assist with the video. So we need to figure out how to get these to match. Is it possible to write 64 as 16 to the something power? No. So what I need to do is change both of them. All right? So what we want to do is think about things that we know. I know that this is 8 squared, but I can't write this as an 8. So we got to keep thinking. Any ideas? Okay, there's another one too. Do you know? Yeah. Perfect. So both of these are powers of 4. So I'm going to replace the 16 with 4 squared. And I'm going to replace the 64 with 4 cubed. Now, The suggestion was made to use 2, which is absolutely fine. The only difference is your equation that you're going to solve is going to have larger numbers, because if the base was smaller, the exponent would be larger. All right, so now I'm just going to rewrite the rest of the problem, and x plus 3. Okay, so now the base numbers are the same. So what we need to do is solve the equation that we get from the exponents. All right, now this one looks a little bit weird, but on this side we have 2 times x minus 5, and on the right side we have 3 times x plus 3. So what we need to do here is some distributive property. So left side should be 2x minus 10. Right side should be 3x plus 9. So now we just need to solve. So we could subtract 2x over here, which would give us x. And then we could subtract 9 over there, which would be negative 19. So x is negative 19. Any questions on that? All right, let's do one more really fast. Just to show you that it's possible to have these as inequalities, there is no difference. So 4 to the third is greater than 8 to the x minus 5. Okay, so process is the same. First thing we have to do is get matching base numbers. So I'm going to look at this. And is it possible to write 8 as 4 to the something power? No. So since it's not possible, I need to look at changing both of them. And both of these are powers of 2. So I'm going to replace 4 with 2 squared. And I'm going to replace 8 with 2 to the third. So now we have matching base numbers, and the rest of it is the same. But again, just to make this point, I'm not changing anything. I'm just rewriting the numbers in a different way. So the value of this equation is exactly the same as it was a second ago. All right, so now we need to solve this time we have an inequality. So solve the inequality that we get from the exponent. So on this side, we have 2 times 3, which is just 6. Is greater than, and on this side we would have 3x minus 15, because remember, just like in our last example, this would be distributive property right here. All right, so let's see, I need to add 15 to both sides, so that would be 21 is greater than 3x. Divide by 3, so x is less than 7, which you could write as that. So what this means is that there's multiple answers. As long as x is smaller than 7, this problem will work out. All right, if you need to go back and rewatch anything, remember that's the purpose of having the video, and we will work more together with some practice.